All right, 4.3, day 1. So y'all, 4.2 was understanding parts of an angle, standard position, understanding and recognizing what theta was. We're about to drop those angles on a coordinate grid. So if you notice where it says adjacent and opposite, that's going to be replaced with the x coordinate and with a y coordinate. And instead of the hypotenuse, it's really going to be a radius, because we're taking a triangle and we're rotating it around the origin. It's going to create a circle. So what's not on this picture, but you should know, is this is the origin right here. Theta is always anchored on the origin standard position. So, guys, as we move forward on this, here's where your true pre-cal stuff starts coming into play. Y'all, cosine is x over the radius. We don't really even think about adjacent over hypotenuse. It's the x coordinate over the radius. Sine value is your y coordinate over the radius. And your tangent are the coordinates divided. It is the y value divided by the x value, which turns into sine divided by cosine. So we do still have our reciprocals there, and that you just flip them upside down. I'm not going to give those reciprocals too much attention. Just remember they are reflected upside down. All right, so now let's go ahead and take a look at 4 examples for 4 quadrants. All right, guys, right here for example 1, it is going to have an angle in quadrant 1, little baby angle less than 90 degrees. They didn't give us the ordered pair, they gave us the measurements of the triangle. But if this is 6 and this is 8, then I know that ordered pair right there is 6, 8. And that is in quadrant 1, they're both positive. The x is positive and the y is positive. So guys, cosine is going to be the x value of 6 over the radius, which is 10, but of course that simplifies to 3 over 5. And then for your sine value, it's going to be the y coordinate of 8 over 10. And of course that simplifies to 4 over 5. Tangent. Y'all, for tangent, look at the ordered pair and just divide the ordered pair. But the y goes on top. So this is going to be 8 divided by 6. And y'all, that simplifies to 4 over 3. All right, secant, cotangent. Y'all, just flip those upside down. Just remember, if the sign is positive, it stays positive. If the sign's negative, it stays negative. So, regular secant. Regular secant is going to be 5 over 3. Cosecant is going to be 5 over 4. And tangent, with cotangent, is going to be 3 over 4. And then, if you still have your highlighter, grab your highlighter and highlight the values that are positive. And if you highlight the values that are positive, it is all of these. I'm just going to make one long triangle, or rectangle. One rectangle all the way down. Highlighted all of them. So remember what that means in quadrant 1. I'm going to write a little summary. They were all positive. All those trig ratios were positive in quadrant 1. All right, let's go ahead and analyze what's going on over here in quadrant 2. So in quadrant 2, I notice that I have an angle larger than 90 degrees. And I know this ordered pair right here. This is a -5, +12. That is the ordered pair that this angle goes through. All right, let's go ahead and find cosine. Cosine is going to be negative, guys. Cosine theta is going to be -5 over 13. Sine theta is going to be 12 over 13. And tangent is going to be the division of these two. 12 over -5, y'all, is going to be a -12 fifths. All right, let's just flip those upside down. So secant is going to be a negative 13/5. Cosecant is going to be a positive 13/12. And then cotangent is going to equal a negative 5/12. All right, grab that highlighter and highlight the positive. It's not all of them. It's only a couple of them this time. So in quadrant 2, sine was positive. What else was positive? What else did y'all highlight? Cosecant. Very good. Good way to say that. Cosecant. Now, guys, remember, cosecant's based off sine. So when I write a summary right here about quadrant 2, I'm just going to say that sine is positive, because if sine is positive, then I know cosecant's going to be positive. Only sine is positive in quadrant 2. Let's analyze what's going on in quadrant 3. So for quadrant 3, we have a pretty big angle. We know it's going to be greater than 180 degrees. And if you notice, they gave us the ordered pair. It goes through point -2, -2. So I know that cosine is going to start with the x-coordinate on top, and we're going to divide it by the radius, but the radius isn't given. So to find the radius, you're just going to square both of those coordinates and add them together, then square root it. It is just the Pythagorean theorem. So look, here's your x squared. Here's your y squared. That's going to give you your radius squared. Y'all, when you square these and add them up, what is it? What's 4 plus 4? Yeah, it's going to be 8. We got to take the square root of this. That's the radius, but there's a perfect hiding out in there. Y'all, what does this simplify to? 2 square roots of 2. Perfect answer. Now remember, y'all, this is a radius, so it's always positive. Radius is an actual measure. It's the measure from the center to the edge of the circle. So always, always, always make sure you write this as positive. Let's just try to squeeze this in right here. All right, so that's going to be 2 square root 2. All right, then we know the denominator. It's going to be 2 square root 2. That is really ugly. That whole number 2 on top and this 2 right here, that's going to cancel out. So then it's going to turn into -1 over root 2. And that's still really ugly, guys, but I'm going to flip that upside down for the reciprocal before I rationalize. So if cosine is -1 over root 2, then secant is -root 2. Any questions on that? You just flip that upside down. Let me go back and clean this up, guys. All right, so when I rationalize the denominator, it's going to be -root 2 over 2. What is sine going to be? Sine is y over radius. What is it going to be?
It's the same, right?
It is exactly the same. Y'all can just recopy that. The negative sign and everything. Good job. So sine is going to be -root 2 over 2. Let's go ahead and recopy cosecant. Cosecant is -root 2. All right, now all we got to do is knock out the tangents. Remember, tangent, you divide the coordinates. Y'all, the coordinates are the same. What happens when you take something and divide it by itself? What's the answer? That's right, it's a 1. Tangent's 1. What happens when you flip 1 upside down? Nothing, it's still 1. So tangent and cotangent are both 1. All right, y'all, grab your highlighter. Let's highlight what's positive here. What's going on? What's positive in quadrant 3? Tangent, very good. So just these whole numbers were the only things that ended up being positive. So in quadrant 3, we just had tangent that was positive. All right, almost done, y'all. Let's take a look at what's going on with quadrant 4. So remember, for quadrant 4, it's a pretty big angle. It's greater than 270. Again, they gave us the ordered pair here. So we know this distance is 3. We know this distance is -3. We do not have the radius. So you're going to have to find the radius again. Pretty simple. Instead of 2's, they're going to be 3's in here. Well, actually, one of them is just a 3. The x is positive. The y is negative. So that's going to be 9 plus 9. That's not an 8. What do I need to put in front of here? Yeah. All right, so now we need to square root 18. It almost looks like this, but what's on the outside? What is this simplified to? 9 times 2. All right, so for the radius on this, try to write in the best you can. I know it's small, but try to write 3 square roots of 2. And then let's analyze what's going on for cosine. So for cosine, we're going to have our x value of positive 3 over that radius of 3 root 2. Those are going to cancel out. That's going to be 1 over root 2. I'm going to flip that upside down for secant in a minute. I'm going to go ahead and rationalize this time. So when I rationalize this, this is going to be root 2 over 2. Let me go ahead and flip that upside down for secant. This is going to be a positive 2. It's positive root 2. All right, so for sine, y'all, it kind of looks like cosine, but remember it's -3. So this is going to be -3 over the radius of 3 root 2. And that's going to be -1 over root 2. And that's going to rationalize to negative root 2 over 2. Again, let me go back and flip this upside down for cosecant. So -1 over root 2 is negative root 2 for cosecant. All right, y'all, tangent. Take the y value, divide it by the x value. What's -3 divided by +3? -1. And again, when you try to flip -1 upside down, nothing really happens. It's still -1. That was a lot of work, but can y'all find the 2 positives? There's only 2 positives. What are the 2 positives? Cosine and secant. Very good. All right, these 2 guys right here. So in quadrant 4, the only thing that's positive in quadrant 4 is cosine. So all of that little exercise, all of those notes is really for this right here. Y'all look, draw a little baby x and y axis, just a little baby one. And we're going to write a little statement that says, all students take calculus. All students take calculus. What that really stands for is, in quadrant 1, all trig functions are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. In quadrant 4, only cosine is positive.